Hi guys, welcome to my update/demo of my homebrew computer system. This is hobby 8-bit general purpose computer system based on MOS technology 6502 processor. I use 2 MHz version of this processor in my circuit by Rockwell. I started this project many years ago, but it was for a long time in hibernation to reactivate my hobby interest in electronics and digital electronics. So after a long break, I started to assemble some of the more permanent prototype parts. Originally this computer was built entirely on the breadboard. Now I have my motherboard already assembled with 2 cards in it, the CPU card and serial port / UART card. So the architecture, the basic architecture of the system is that it's based on the buffered bus. The bus is divided into 2 parts, the CPU part and buffered input-output part. The input-output part gets 4 slots here. The total number of input-output designated address spaces from the address decoder is 8. But the expansion cards will get only 4 slots, from 4 to 7, and slots 0 through 3 will be designated for the internal purposes. So the UART card is based on the Motorola 6850, and here is the CPU card. CPU card consists of Rockwell 6502 AP processor, EEPROM, base 32 kilobytes of RAM, and CPU clock / oscillator and address decoding circuits. All of those signals from this card are going to the external bus that goes into the motherboard. And the buffered part is input-output part. I use 3 transceivers, 74245, and currently I'm testing my real-time clock circuit, and I will be assembling here my banked RAM memory, but I don't have it wired yet. I only wired the future bank selection register, which is made out of a latch register 74374, which now I have basically connected to the data bits, the data bus, and the output of it is connected to the 8 LEDs that will show me the status on the latched part of the register. So I struggled for some time with the errors in my design and bad solder connection on my motherboard, but finally got the RTC circuit working, and I have a little program here that can demonstrate that it works. I set up the clock and data earlier, and as you can see, it keeps the time and the clock is running. I also already powered down and powered up, back up again the circuit, and the time is still kept properly, so the battery backup is also working properly. And as for the latch register, it's under the in the address space of C00 to C0FF. So if I write anything into the address C000, I should have the binary equivalent displayed by those LEDs. So if I do FF, I should lit up all the LEDs on the breadboard. And all seems to be working here. We can test some of the bits, like the least significant bit here. Seems to work fine. Now the most significant bit. It also worked. Let's do some other value, like maybe 03, which will be the two least significant bits. And all seems to be working fine. So a little bit more about the real-time clock circuit. So this circuit is based on the DS1685 chip, and this chip has a multiplexed bus. However, 6502 has a regular full bus with non-multiplexed bus with all the address pins and data pins that are separate and not shared. So it was a little bit tricky to connect that chip to this kind of bus, but there are ways to do it, and I first figured a way to do this logic with 3 NAND gates, which was a solution that came by independently, but apparently other people also came by it, and I found very similar circuits or identical circuits on the internet. But this didn't work very well. It was very sensitive to the propagation time changes. When I ran the signal through 1 or 2 more gates, it would stop working. So finally I decided to use the solution that I found on a fellow hobbyist project page, Chris Ward, where he used address decoder 74138 to cleverly connect this bus to the 6502 CPU bus, and by simple trick in the software, in the programming, the multiplexed bus can be emulated. So I am pretty close of finishing my prototype of banked RAM and RTC circuits, and once everything is tested and working, I'm going to assemble another card which will sit into this slot. Thank you too on this bus side.